So the Carnot heat engine, refrigerator and heat pump. For the Carnot heat engine that operates on the reversible Carnot cycle. So the most efficient of all heat engines operating between the same high and low temperature reservoirs. So this is example of the heat engines. So this one is reversible heat engine, this one is irreversible heat engine. So you have to remember that irreversible heat engine always lower than reversible heat engine. Okay, so if the reversible heat engine has already have 70% performance, therefore if you find another reversible heat engine which having the same TH, having the same TL, okay, so your that heat engine cannot reach the thermal efficiency of 80%. It is an impossible heat engine because this one is the best. Okay, this one is possible because it is irreversible and it is less. The thermal efficiency is less than reversible heat engine, so this one is possible. But this one is impossible, right? Because the highest of reversible heat engine that you can get 70% for this example. Okay, for this example, as long as the all the informations are the same. Okay, so how do you identify that? The thermal efficiency for reversible is equal to 1 minus TL over TH. Okay, this is the equation. So where do you get this equation from? Actually, this is coming from thermal efficiency equals to 1 minus QL over QH, remember? But this time we are replacing the QL over QH, okay? So for any heat engine, this is irreversible, right? This is irreversible heat engine or any heat engine. Okay, you use these equations, right? But for Carnot heat engine, you are using this equation, reversible. This one is for irreversible. These things that actually being discussed before this, okay? It's not a Carnot, using Carnot cycle. So this one, reversible, is always better than any heat engine. Okay, so when you calculate, when you identify from your calculations, when the value is lower than reversible, then it is irreversible heat engine. So if it's equal to your value, okay, the reversible thermal efficiency, it is reversible heat engine. But if it's bigger than your calculation value, so it is an impossible heat engine. So for Carnot heat engine, you need to calculate this first. If you want to compare what kind of heat engine that you are dealing with, so you need to calculate reversible heat engine first, find out the value, okay, make it as your reference. Then you calculate the next heat engine and identify whether it is irreversible or reversible or impossible heat engine. So please calculate this first, okay?